Well, good afternoon, and welcome to the first of two tech sessions by the Tactical Technology Office here at D60. I'm Tom Beutner. I'm the Deputy Director for TTO, and 10 years ago I was actually a program manager in TTO as well. It's great to be back at DARPA and to be part of our 60th anniversary celebration. If you were fortunate enough to attend TTO's plenary session this morning, then you heard Fred Kennedy, the TTO Director, talk about how the office is pursuing a strategy of enterprise disruption. For those of you who are not able to attend, simply put, TTO's vision is to pursue disruptive capabilities for the future of warfare. Now, by design, those capabilities will be disruptive to our adversaries. And by necessity, they may also be disruptive to our current tactics, our current platforms and architectures, and the way we think about combat in 4 different zones that TTO is pursuing. I'll be leading this afternoon's panel discussion with some of our program managers from TTO who will discuss their visions on the disruptive nature of future warfare that they're pursuing in the space and maritime domains. And tomorrow morning we'll follow up with a second panel discussion on the air and ground domains. We'll be discussing some concepts that extend the capabilities of our existing systems, making them more robust, survivable, or lethal. And we'll also be discussing some ideas that we have for a vision of disruptive capabilities and approaches that may be very different from our current strategies in each of these domains. DARPA is celebrating its 60th anniversary, and over the past 6 decades, our defense industry, partly in response to DARPA's initiatives, has developed and refined its ability to design and build extremely capable and complex systems that have supported the country for everything ranging from counterinsurgency to conventional warfare and even nuclear conflict. No country has ever done that better, and no country has ever invested as much in doing so. And although there have been attempts to counter that trend towards increasing complexity and cost, they've generally faltered as the acquisition community has incentivized performance over both cost and schedule. But the problem with these exquisite systems, as Fred Kennedy talked about this morning, is not only that they are expensive, but that they can take decades to go from the initial requirements definition to a fielded capability. And that means our adversaries have decades to study our approach, to come up with countermeasures, and sometimes to field those countermeasures even before we've reached an initial operating capability. We live in a world today where domains that we once considered sanctuaries, air, sea, and space, are now contested, and platforms and systems that we once considered invulnerable are now being targeted. So it follows that the force structures that we once considered stable and resilient for decades must now either adapt or be replaced. It may no longer be practical to assume that we can anticipate future threats and their movements and field a force structure that can be maintained for decades. More than ever before, we need to adapt and to surprise the enemy. We need to counter their assumptions and introduce uncertainty into their planning. We need to disrupt the enemy and force our adversaries to question their assumptions about how, when, or even if they can engage us. We're looking to present the threat with a future that is uncertain, with systems that they do not know how to defeat, and with a cost asymmetry that works against them, not in their favor. TTO is engaged in trying to answer the question, what comes next? In space, we're looking to pivot from the former sanctuary of geosynchronous satellites to a proliferation of small, low Earth orbit satellites with commoditized buses. You'll hear more about our Blackjack program in a few minutes. It's designed to leverage the commercial investments in space and build upon those architectures. We intend to allow DoD to leverage that rapidly growing commercial space market to achieve a space architecture that has global persistence, improved performance and latency, and can be constituted, reconstituted, and refreshed much more readily than our current space assets. And we're looking at options to extend our access to space as well, to complement that responsive space enterprise. You'll hear more about DARPA's Launch Challenge in a few minutes as well, and how we hope to expand the options and responsiveness for on-demand launches in the future. We're also looking at novel on-orbit propulsion techniques that provide better mobility in space. and form a foundation for a flexible space operations in the future. And you'll also hear more about RSGS, a new approach to servicing satellites in the future that may allow us to inspect and repair satellites on orbit, including some satellites that are already up there. The space and maritime domains both suffer from the tyranny of distance, and they demand a level of autonomy that allows them to operate with inherent latency and limited bandwidth issues. Figuring out how to operate in these domains with autonomous systems gives us an asymmetric advantage in the future battle space. You'll hear more in a few minutes about an approach to begin taking full advantage of that autonomous operation from the ocean floor to space. And one recent example is the anti-submarine warfare continuous trail unmanned vessel, or as it's more commonly known by its acronym, ACTIVE. It's an unmanned surface ship that recently transitioned from DARPA to the Navy. And although it was originally envisioned as an alternative way to perform anti-submarine warfare missions, it's now enabling a new class of vessels, and it's being used in experiments to determine the capabilities that a long-duration unmanned surface vessel might provide to the Navy in the future. At DARPA, our job is to avoid the technology surprises from the adversary and to create technology surprises that can be imposed upon them. Some of the ideas that we pursue push the limits of what can be done. Not everything you'll hear about in the panel discussion this afternoon will make it into the future force structure. And that's okay. We're interested in exploring the art of the possible. And we've constructed these sessions as an opportunity for our program managers to share their specific insights with all of you. And we'll have an opportunity at the end to take a few questions, I hope, if time allows, so feel free to put those in through the D60 app as we go. But my hope is that the next hour is just the start of a discussion with all of you that will go on from here to engage on ideas that are useful, game-changing, and feasible. We're always interested in hearing about your ideas. And so with that, I'd like to introduce our panel members who will provide a little bit more insight and detail on their programs and their visions for the future. Todd Master, Joe Parrish, Rusty Thomas, Andrew Nuss, and Xander Wallen. Just a few of the program managers who are helping to turn that vision into a reality. So Todd, let's start with you.
All right, great. Well, thanks, Tom, and thanks everyone for coming. I'm sure you'll be very pleased that you've clearly made the best choice of all the panels you had to choose from for this hour by the time we're done. So, my name is Todd Master. I'm one of the program managers here for efforts in our space domain. I actually have dedicated my entire career to space, beginning as an active duty officer in the Air Force, and then progressing on to a series of different jobs across private industry, commercial space launch, worked as an Air Force reservist, worked on national space system development, and finally joined DARPA here in April of 2016. Upon getting here at DARPA, I actually inherited a program called ALASA, which some folks might be familiar with, was an airborne space launch effort that we had underway. But I've also started a few of my own, and we're going to talk a little bit more about those in the next couple minutes. But today, really what I wanted to talk about is three real things. First, my vision for the space domain. Second, to give you a little bit of an overview of the programs that I'm working on. And then finally, to discuss opportunities that I see for the future on how we can avoid and create strategic surprise, specifically in the space domain. So really, when it comes to my vision for space, something that's really important to me is we've here at DARPA spent over 30 years looking at how we can enable responsive, flexible space launch. We've had a number of programs in this domain with varying degrees of success over the years. You heard some discussion of those, I think, in Dr. Walker's talk this morning and Dr. Kennedy's talk. Pegasus, Taurus, Falcon, Rascal, ALASA. We actually have another program right now called Experimental Spaceplane that we're pursuing with some different technology goals. And I have a program called DARPA Launch Challenge I'll talk about in a few minutes. But the question is, DARPA, we're always supposed to be looking to the future. Why do we continue to pursue this after all these years? And the answer is that the vision is still very much appealing. This is something that we haven't quite achieved, what we've been wanting to achieve after all these years. But we have seen a lot of progression in terms of capabilities in technology. And we really still do believe that, or at least I believe that there's still a very strong future in tactical use of space. Today we still use space in a very strategic manner, I think in the future we can use it in a more tactical manner, and flexible and responsive space launch is a big piece of that. We also think that it's an enabler for resilient architectures, the things that we talked about with, Dr. Kennedy talked about with Blackjack earlier today. We see a future of more resilient architectures enabled by disaggregation of lots of small spacecraft. Small launches, you can argue there's a chicken and egg approach. Do we not have an architecture of small systems because we don't have a flexible and responsive launch capability? Or is it the other way around? So we're actually trying to hit that from both ends, and small and flexible space launch is a big piece of that. In addition to that, we also see that as an enabler for faster technology refresh. We talked again how that's sort of a part of the Blackjack program, but the ability to put things on orbit quickly, put things on orbit wherever we want to, that really becomes an enabler to be able to do that, is to have that flexible launch capability. So that's why we continue to pursue that, and I still think that that's a capability that we are keenly focused on for the future. Other things with regards to future vision is really we're seeing a democratization of space. The ability for things that could only be achievable by a handful of nation states, really two for a very long period of time between the United States and Soviet Union, have become available worldwide through globalization and through technology development. So those things are available on a commercial basis. Access to space has become democratized. Ability to get data from space platforms has become democratized. So there's really a big change on how that's worked. We're seeing an advent of really new operations, especially from commercial providers, with regards to astrodynamics, things that are much more complex than what we've undertaken in the past. Rendezvous and proximity operations, on-orbit inspection, servicing, on-orbit upgrade. My colleague Joe Parrish is going to talk a little bit more about that, but that's a big part of the vision that we see for the future. And then really all of these new capabilities will lead to a fundamental transformation of the way that we think about the way that we operate as a military, and as the way that we operate and take advantage of commercial capabilities. And this really goes through the whole life cycle. It's everything from the way that we procure systems, to the way that we build systems, to the way that we operate systems, to the way that we get data from space. All of those things are influenced by this sort of future vision. So now that I kind of talked about that vision, let me shift to programs. Part of what DARPA really does with its hiring of program managers is to bring us in, bring forward a vision that we have, and then formulate and execute programs that bring that vision into reality, to fruition, before the future sort of naturally progresses there in 20 or 30 years. We're trying to accelerate those capabilities. So today I'm going to talk to you about two programs that are trying to help bring that future forward. First, I'm going to talk about the DARPA Launch Challenge. So I talked about the pursuit of responsive launch, and Launch Challenge is one of the ways we're doing it. In the DARPA Launch Challenge, successful competitors are going to be required to do 2 separate space launches from different launch sites on very short notice. We're talking days to weeks. This is a process that usually gets planned years in advance. Minimal notice and minimal prior knowledge of the payloads that they're going to have to launch to orbit, the orbits that they're going to launch to. It's really kind of turning the paradigm of a very carefully, cautiously, long-term planning for space launch, which has led us to slow progress in space, and turning that on its head. And really those goals are intended to reflect the way that we want to use space in the future. We want to make more tactical use of space. We won't know what we need to launch or where we need to launch it until it's actually military demands demand it. So DARPA Launch Challenge is intended to sort of be a microcosm of how we see that future. So it's not necessarily that it's a new problem that we're trying to solve, but it's a new approach to how we're trying to solve it. And specifically, DARPA Launch Challenge is really trying to take advantage of the challenge model. And we have a panel later this afternoon. I'll give a plug on use of prize-based challenges that I'll be on. But back in 2004, 2005, DARPA initiated its first challenge with DARPA Grand Challenge. We continued on that progression with a few over the years of other sort of grand challenges, and Urban Challenge and Cyber Grand Challenge. But there's times that a challenge model is opposed to sort of a traditional procurement, where we put out a statement of need and we make a selection and we sort of do a down select and people submit proposals and we review them. A challenge really turns that around and just rewards results and is sort of indifferent to the technology approaches by which we get them. And that really aligns very well with how we would like to use space in the future. But what were the motivations, and how was it that we decided to make this particular thing a challenge, where we saw a lot of commercial momentum, we saw a lot of industry momentum, we saw billions of dollars in private capital going into space projects and investments in space. So that really the capabilities that a lot of there's sort of an emerging field of commercial competitors. There's over 50 private companies just in the US who are looking at developing small responsive launch vehicles. So what we really want to do is we're very interested in these capabilities. Most of them supported the types of goals that we're looking for in terms of agility and flexibility, and elimination of sort of one-of-a-kind fixed launch infrastructure. So we are really interested in those capabilities, but it was hard to suss out sort of which of those capabilities was real and which wasn't. And the challenge gives us a really natural way to sort of say, if you're able to produce results, you're able to put 2 spacecraft in orbit within a matter of weeks with little prior notice, you can win over $10 million in the challenge. And so that really helps us promote a field instead of choosing one particular winner. And really what it helps us do is send a demand signal to industry that this is the way that we would like to use space in the future. It sort of shows the rest of the military capability that they may not today realize is on the cusp of existence. So it really lets us reward industry for results and provide that existence proof. Launch, where our real goal here is to shift that. A space launch today is a national event. We shut down airspace, we have to plan it long in advance, we bring up all these resources, and we're trying to really demonstrate that it doesn't need to be a national event, and it cannot be a national event in the future if we want to use space the way we want to. And Launch Challenge will be a microcosm of that. We have some really key partnerships on this project. FAA is doing the commercial licensing of these launch vehicles, which is really critical from our perspective on finding a commercial tail with commercial customers and for us to procure them in the future. It gives us a really flexible contracting mechanism in the future that we can use if we're able to use commercial mechanisms. Air Force Space Command is also keenly interested in what we're working on, and we're working out details on the potential partnership with them right now. So switching gears for a moment, so that's talking about the aspect of how we get to space. Once we're actually in space and doing advanced operations, I have a different project called confers, or the Consortium for Execution of Rendezvous and Servicing Operations. Very clever acronym that, of course, we must have at DARPA occasionally. And I would say this is an unusual DARPA project, but a lot of people will say an unusual DARPA project is sort of redundant because we do a lot of unusual projects. But this is unusual in that it's a government industry consortium that is seeking to develop and publish standards that address responsible on-orbit operations, specifically for things related to rendezvous, proximity operations, and on-orbit servicing. What you have to realize is that typically our goals in space are to, or traditionally the way that we've done it is, we launch objects into space, they operate and collect data from the ground or do some other function, and we're trying to avoid other space objects. But with a lot of on-orbit servicing and on-orbit inspection type missions, we are actually very intentionally bringing 2 objects together, which brings with it inherent risks. So what we really want to do with confers is sort of define what we call the rules of the road, things akin to what we do in other domains, what we do in the maritime domain with coal regs. And it really brings together both government, who has a wealth of experience in this arena, and industry, who has big business interests in what they see as a future of this arena. And this includes some really key partners also from across the DoD, but NASA is a key partner on us as well. NASA's been doing rendezvous and proximity operations since the 1960s, primarily with manned missions, but they have a wealth of experience that they're helping bring to the table and help work with industry so that we can define a set of standards. And the real goal of developing those standards is that it helps build confidence. It helps build confidence for regulators, it helps build confidence for investors, and most of all, it helps build confidence for customers, both government and commercial. These are new, complex operations that are hard for a lot of people to understand, and it's hard to understand whether or not Company A or Company B is acting responsibly. And the reason why it matters is these are critical issues that need to be addressed because there are high-stakes operations. So to date, we really have achieved great industry collaboration, and we've had a series of standards workshops with technical experts who are working to develop these right now. Within the next year, so upcoming at the end of September, we have a workshop in Bremen. So if folks are interested, we have some flyers at our actually right at the RSGS part of the TTO booth. But we have a workshop in Bremen where we're continuing to work technical standards, a little bit more opportunity for us to engage so the European commercial community. And then at the end of our first year of our project in November, we'll culminate with a global satellite servicing forum in November in Falls Church. So again, you can find more info at the TTO booth or come find me and we can talk about it. But this is unique in that we're not developing widgets or platforms or algorithms, but we're really trying to create a set of widely adoptable standards that helps promote a nascent industry that we see as critical to the future of expanding commercial space. So finally, what does the future hold for space? So I talked a little bit about a vision, I talked about programs, but what do we see is coming in the future? So I think, as I've sort of alluded to, is we see big changes in the way we do space launch. So I think new ideas about what really constitutes a launch range. What do you really need from a range from an infrastructure standpoint? And what we'd like to be able to move to is really an elimination of need for fixed ranges with exquisite infrastructure. We see a huge coming frequency of launches and a boom of affordable small launch vehicles. And really what we want to shift to is more of the way that we look at something like FedEx or UPS. When you ship a package by FedEx or UPS, you have a destination you want to get it to. You want to ship something and you want it in California by Wednesday. You don't care if it gets there by one truck or two trucks or a plane or a boat. You just want it there when you want it. And that's really, frankly, the way we'd like to use space launch in the future. I think another sort of future, what else does the future hold for space? I think you're seeing we cannot ignore the big private investment that's happening and leveraging that to our advantage in DoD. I think you already see that reflected in a bunch of programs that we're running. So Launch Challenge specifically is a unique approach to that. Blackjack is a unique approach to that. RSGS and Experimental Spaceplane are both OTs where we've signed commercial partnerships with industry. So you're already seeing DARPA adopting and leveraging ways that we can take advantage of commercial investments in space. Space traffic management has been sort of a hot topic of discussion, and it's been, I'll call it a curiosity to some extent, but it's really a necessity, and that's going to be something that I think you're going to see worked, or needs to be aggressively worked in the next several years. And that really needs to include both on and off ramps. So today, we're very focused on, a lot of people when they look at space traffic management are just focused on conjunction and avoiding conjunctions, but comprehensive space traffic management needs to include both proliferation of space systems, the addition of new systems routinely with frequent launch capability, disposal of old systems that are no longer functioning, and cleanup of debris. All those things need to be part of space traffic management. I think in the future we're also going to see a shift to constellations that are updated on need, not on fleet management plans. Today everything is sort of planned on planned obsolescence or extended life. I think we're really going to see a shift to launch and build and launch on need. I think we're going to see a future of unique new space systems that would never survive on their own because they couldn't or could never exist today because they cannot fit in a single launch vehicle, or they could never survive the launch loads. But I think through things like on-orbit fabrication, on-orbit assembly, we're going to see new space capabilities that we can't even envision today. And finally, I think you're going to see some dramatic advances in propulsion, which are largely enabled by modern nuclear reactors in space. This really is going to be a coming thing that we're going to see is going to change the way that we are able to navigate everywhere from here to everywhere within Earth orbit and beyond. And really what that lets us do is start to open up the ability to use orbits that are not reachable by traditional chemical propulsion means. And really from a military perspective, when we look at the way we operate in other domains and military goals of outmaneuvering and outrunning adversaries, new propulsion capabilities are going to be necessary to maintain that same advantage in those domains. I think you're going to see more tactical space systems, as I talked about, rapid deployment. I think you're going to see missions that we can only achieve today by air, but we're limited by doing them by air because of access to foreign territory or sovereign territory. I think you're going to see a lot more of those missions taken on by space as costs come down. And finally, I really think we're going to see a future of space that's very transparent. We're already starting to see it today. Things that advanced space operations that people are taking on with regards to RPO or debris shedding, things that previously we would just have been ignorant to, that are now showing up on certain publications like Space News obviously covered this, but you're even seeing this in mainstream press. And it's partly because there's an increased public awareness and increased public interest in space that, coupled with new technologies, is basically going to serve for space transparency, which makes the status quo and nation states uncomfortable, both ourselves in the US and our adversaries. So we need to figure out how we operate in that transparent domain. So really all of these things I think are going to change the way that DoD procures, builds, operates, and launches space systems in the future. And I think it's all going to be significantly altered as a result of these changes. And we at DARPA are really seeking to bring those changes forward as quickly as possible. So now I'm going to hand the stage over now to my colleague Joe Parrish, and he's going to talk about a program he's working on that's trying to bring some of those capabilities, future capabilities forward now too. Joe.
Great. Thanks very much, Todd. Welcome to D60. I'm very happy to talk to you about a really cool space robot program that we're working on called RSGS that we're doing in the Tactical Technology Office here. By way of background, I've been involved in space robotics for most of my professional career. I started working with robotic systems on the International Space Station, and most recently came to DARPA from the NASA Jet Propulsion Laboratory, where I was working on robotic missions to Mars, including a really neat mission where we actually capture a sample of Mars material in Mars orbit and return it to Earth. So, if you will, allow me to set up a scenario. It's kind of a crazy one, but just bear with me because I want to make a point. Imagine, if you will, that when your car runs low on gas, instead of going to a gas station, you drive your car to the junkyard and abandon it. Imagine a scenario, you go out to your patio to have a nice dinner, and your cafe umbrella, you know, the one that you have to crank up, you know how they always stick? And usually you just reach out and kind of jiggle it with your hand and it unsticks and off it goes. Well, imagine instead of just reaching out and jiggling it and everything is fine, imagine in that case you throw away that cafe umbrella and you don't bother to use your patio for the rest of the summer just because it's stuck. Imagine once you move into your house for the first time, you're never again able to bring in groceries, to call a plumber, or to bring in a new TV set when a new technology comes along that makes that compelling. So these things sound crazy, but this is exactly what we do with billion-dollar assets in geostationary orbit when they have a problem or they run out of consumables. So our vision at DARPA is, instead of accepting the demise of these billion-dollar assets just because they've run out of fuel or just because a solar array fails to deploy, we lose the entire mission, we're developing RSGS, and that stands for Robotic Servicing of Geosynchronous Satellites. And it's working to enable routine servicing of these valuable assets in GEO. That ability to service and upgrade these assets dramatically improves the resiliency of our orbital systems, and it sets the stage for a future where servicing is a routine aspect of space operations. We're exploring a variety of technologies to enable us to inspect, repair, reposition, upgrade, assembling satellites remotely, and that's going to reduce the cost of GEO operations and enhance both our current and future capabilities in this very important domain. So let me tell you a little bit more about RSGS. The goal with RSGS is to create an operational, and when I say operationally, I mean not just a demonstration, but true operational capability for dexterous robotic servicing in geosynchronous orbit. It's going to enable increased resilience in our current space infrastructure and serve as a first concrete step toward a transformed space architecture with very revolutionary capabilities. And these capabilities include the ability to cooperatively inspect spacecraft, cooperatively assist with adjusting their position in the GEO belt or rising or bringing down from between the operational and the graveyard orbits, cooperatively correcting mechanical problems with array deployments or antenna deployments, and cooperatively installing self-contained payloads on orbit. So in addition to all the fantastic technology that's going to have to come into play to make that possible, we're also pioneering the way in which we develop the system, and we're doing it in a very innovative public-private partnership with Space Systems Loral, SSL. We instantiated that partnership in April of 2017. The payload and the spacecraft bus development are already well underway. We just had our preliminary design review for the payload at the Naval Research Lab, who's developing the robotic payload for us. That was completed in July of this year. In October of this year, The system requirement review for the spacecraft bus will happen up at SSL's facility in Palo Alto. And the long lead items like the robotic manipulator arms, those are actually, the flight arms are already in production. So we're driving forward for the development of this system. We're planning to launch it in the spring of 2021. We'll have a 6 to 9 month checkout period. And then once that checkout period is over, DARPA is going to turn the spacecraft over to SSL to operate for fun and profit. They intend to service 20 or more GEO satellites, government and commercial, a combination of those, over a several-year mission lifetime. And this is what makes RSGS different from all of the missions that preceded it. This time, we're actually going to operate on multiple clients, and we're going to do it for real in an operational scenario in a commercial environment. Success with RSGS is going to open up some incredible future opportunities. Routine servicing of our valuable assets, not just in GEO, but the technologies that we'll develop in RSGS are also applicable to medium Earth orbits, like where the GPS satellites are, and even low Earth orbit constellations. And we'll be using the standards for operations and interfaces that are developed under Todd's confers program. And then we think that we actually might have application for the LEO constellations like you'll be hearing about from Rusty Thomas in the Blackjack program. In the case there, you might have thousands of satellites that are involved in a constellation. Some of those satellites are going to fail, and somehow those satellites are going to need to be removed from their orbits so they don't become orbital debris. And we think that's a fantastic application for on-orbit servicing to play that role. So there's a role for on-orbit servicing all through space in just about every orbit that you can imagine. We're also imagining a future where we have automated space logistics, where we can bring new fuels, new payloads, new tools to service spacecraft and deliver those things autonomously between LEO, GEO, and the clients that need to be operated on. We're imagining a future where we have modular spacecraft, where you have orbit replaceable units that are the payloads on those spacecraft, or even the core systems. So it's a new paradigm that's enabled by on-orbit servicing. And then finally, the assembly of large apertures, structures, and bases in space are some of the longer-term future applications that we can imagine once we've instantiated this capability for on-orbit servicing. So we think the future is very bright, and please keep your eye out for RSGS. We'll be launching in 2021 and getting underway with our operations in 2022. So thanks very much, and let me hand it over to Rusty Thomas to talk about Blackjack.
Awesome, thanks. Thanks, Joe. Good afternoon. I've been a program manager in TTO since September 2017, when I was fortunate enough to be invited to come from industry and pursue the development of new space technologies for the DoD here at DARPA. My primary motivation as a PM, who spent the majority of my commercial career, my career in commercial space enterprises, is to help the U.S. military rethink its approach to the space order of battle. And I'm here at DARPA to focus on technologies that will increase the resilience, the global reach, the autonomy, and the network connectivity of our space military assets. My background includes positions in commercial and defense companies, and I've developed and fielded communication constellations in low Earth orbit, space situational awareness satellites that track other satellites in space, commercial resupply spacecraft for NASA, and manned spacecraft. During my years working in commercial space, I witnessed how high speed, high energy, and cost as a design factor approach to space technology development could yield creative solutions with low recurring costs that allowed access and utility of space missions to go up by decreasing the cost of the access to space and the cost of operating once we were up in space. I hope to be able to leverage a great deal of those commercial approaches to solve future space challenges for the U.S. military. So, what is the big problem that I'm trying to solve while I'm at DARPA? We've heard it before in other sessions, very eloquently. The current military space ecosystem relies heavily on very large, very expensive, and exquisite space assets in geosynchronous orbits that are proven to perform exceptionally well for the DoD and do provide spectacular information that our intelligence community and our warfighters use every minute of every day. By taking the ultimate high ground, these platforms are able to maintain constant surveillance across a large area of the Earth, applying advanced sensors to deliver the desired performance from great distances overhead. Unfortunately, this capability comes at a very high cost, along with very lengthy development cycles. Examples this morning were a decade plus to get these systems up in a lot of cases. As a result, the military is facing a difficult challenge in keeping pace with rapidly evolving threats. It typically takes that decade plus to deploy new space technologies to the warfighter. Standard development cycles for orbital military systems do not allow 1 to 2 year tech refresh cycles. We got to change that. Furthermore, the high ground in orbit is no longer a safe haven from rapidly evolving capabilities of our adversaries. Our large, high-value military space satellites are targets that can be defeated by non-kinetic and kinetic weapons that cost orders of magnitude less than the cost of our assets. In response to these challenges, I'm envisioning a space domain where the DoD and the space industry can leverage the emerging new space, commercial, low Earth orbit, LEO, or I like the term, the mega constellations that are currently under development. These constellations share characteristics that can enable this military leverage. They incorporate low-cost buses. The spacecraft are low cost to start with. High-speed broadband data crosslinks, megabits to gigabit type capability. High-tempo launch campaigns that will put hundreds to thousands of satellites into low Earth orbit, and ground infrastructure to manage at scale the constellations, the subscriber-based network of millions of users, all combined to help us develop a space order of battle architecture that will transform military space. For example, a military constellation of 60 to 100 satellites in low Earth orbit could potentially utilize spacecraft costing under $10 million per node. That includes the launch cost. A pivot to low Earth orbit would reduce our separation from space, those assets in both time and space, and provide deterrence by inverting our adversary's cost equation for countering those systems. If we link DoD LEO constellations to global commercial communication networks, we can provide a resilient, persistent ISR network unlike anything that we've seen before. The present program I want to talk about is the DARPA AFRL Blackjack program, and it's the first step in developing that vision. The program goal is to demonstrate a space order battle, full architecture that cannot be defeated with just a few weapons, and allow 1 to 2 year technology refresh cycles versus the current decade plus that we see now. This will be accomplished through the proliferation of identical payloads across a satellite constellation in low Earth orbit to deliver global constant custody and persistent coverage at an unprecedented low cost relative to assets in higher orbits. The Blackjack demonstration program will launch a sub-constellation of 20 satellites for a demonstration of autonomous military sensors in LEO combined with those broadband communications satellites to military subscribers starting in 2021. To achieve this, the program has initiated procurements with multiple performers under contract this fall, and by next summer, preliminary designs will be completed and the program will select performers to move forward to the orbital testing phase. Detailed designs and initial hardware delivery are going to be completed by late 2020, launch of the first 2 spacecraft in 2021, and 18 additional spacecraft in 2022 that will combine to provide theater-wide demonstration campaigns with all 20 spacecraft collaborating autonomously, enabled by artificial intelligence advances, to provide tactical timeline support to warfighters via this space cloud. DARPA has entered into a partnership with the U.S. Air Force Research Laboratory for the initial program development, with the Air Force contributing technical expertise and funding to support the Blackjack program. And looking forward, with the commercial companies plan to build these large LEO communication constellations ranging from the hundreds to thousands of satellites that will provide global low-cost broadband internet services. There will be key technologies that I mentioned earlier that could really impact the DoD space architectures. First, those low-cost commoditized buses. Spacecraft that cost in the low single-digit millions change the way we can go after it, change the culture, change the system engineering, absolutely changes how we procure, plan for, and operate spacecraft in low Earth orbit. They'll be manufactured at large scale via commercial production lines and integrated with DoD payloads. Low single-digit millions is what we're shooting for. Frequent launches. The commercial providers will require very high launch tempo to deploy and maintain LEO constellations. Constellation management. Commercial companies must solve the large constellation management problem to remain profitable. and the rest of the DoD space can leverage their development and algorithms to reduce our operational cost. And then low size, weight, power, and cost payloads in low Earth orbit, matched in development and production cycles to commercial approaches to provide a communication network and ISR capability to military users at any location on the planet, at any time of the day or at night. Finally, AI development. The future, space systems will need to provide data to our warfighters in seconds to minutes in order to stay inside our adversaries' decision cycles. And the Blackjack architecture will be able to quickly utilize the best algorithms of the next generation of innovation and software systems. Together, these new technologies will drive the future of DoD space, enabling a military pivot to low Earth orbit, and provide a new approach to build military space systems. Thank you. Let me switch it over to Andrew for a totally new domain.
Good afternoon, I'm Andrew Nelson. I have the privilege of carrying the conversation from the space domain to the maritime domain today. So I have two focus areas for today. First is to share our vision for the maritime domain with respect to this enterprise disruption vision. And then second, to share some asks for you as the community to help us realize this vision. So I came to DARPA after many years in the Navy's Warfare Center Enterprise, where I focused most of my career on survivability of our high-value units, that is, protecting and defending our capital ships, carriers, submarines, destroyers. Immediately prior to coming to DARPA, I was at the Strategic Capabilities Office, SCO, where I had the privilege of working on several unmanned maritime systems programs and some cross-domain weapons efforts. So a core of Dr. Kennedy's enterprise disruption vision, if you heard his very vibrant presentation this morning, which I think for the rest of history will be known as the Side of Fries presentation, that vision is really about removing difficult to defend assets from the architecture. So in the maritime domain, we did mention the aircraft carrier, but there are other large, expensive manned capital assets that are in this architecture that we would like to find alternatives for. And it's kind of unique for me as a person who spent most of my career, if not all of my career, trying to find ways to better protect and defend these assets, that here I am at DARPA trying to envision a new architecture to completely remove them from this force structure. So what do we want this force structure, this new vision to do? Well, we still want a system, an overall architecture that is capable of projecting power. That's a key tenet of what the Navy does. And we still want to be able to control the seas, another key tenet of what the Navy and the Marine Corps team do. But we need to be able to operate in contested environments. And I know that that's a very common statement these days, but we need to be able to operate in an environment it's a harsh environment itself. The sea state, the winds and waves and stuff are harsh, but we need to be able to operate in these contested environments where we don't have GPS, we don't have positioning fixes at the frequency that we want, we don't have the communication pathways between manned and unmanned platforms that we desire. But overall, what we want and what we demand is a system that is resilient, something that if we do lose one node or 2 nodes or 10 nodes out of the system, that the overall system of systems is still able to operate. But another important tenet of this is that we want to find a way to have affordable platforms. And sometimes resilience and affordability contradict each other, and here we are at DARPA trying to find ways that they can actually mutually support each other. So what would this vision look like? Well, there's some common themes with our space domain friends here. That is, we're good enough platforms. We're trying to find less exquisite alternatives to the high-value units that we have in the fleet right now. We don't want to be unique. We want to have many things out there that are hard to find and hard to track and hard to engage. We also want to find ways to be able to leverage commercial investments, and I'll talk about this in a moment. And then also find ways to operate and own new regions of this maritime domain that we don't currently operate in right now. So we talk about and we enjoy the value that small systems and disaggregated operations provides, and Alexander Wallen will talk about the active program here in a moment. But what we're looking for is not just a new platform. We're looking at how that platform fits into the bigger picture. How does that small platform get into theater? How is it sustained? How does it communicate? What kind of payloads does it deliver? What kind of persistence does it have? We're really looking at the full picture of this maritime architecture. And in the maritime domain, we're really challenged by the time-distance problem. It's really the time, distance, and the area of coverage problem. There's lots of ocean that we want to be present in at any moment to be able to affect some adversary or provide some delivery mechanism. And we're also challenged in this notion of presence. We want to be everywhere to be ready. We're at the ready to go from phase 0 to phase 2, at the time and place of our choosing. So presence is a difficulty that we have. So what we're looking for is new development approaches, new platforms that enable us to dash or to surge into a specific theater of interest to help close the time-distance problem, but also ways that we can seed and reseed these small systems in the operational theater so that we can gain this persistence. So we do see some growth in commercial investments, not quite on the scale of new space that Rusty talked about, but we do see investments in the maritime domain from the oil and gas industry, or seabed mining has been an area that's always on the verge of breaking for the last 30 or 40 years. But we also see some investments in the European community on really large unmanned platforms. The Europeans have at least 2 consortiums focused on unmanned cargo and container ships. So what we're curious about, what we're interested in, is ways that we can leverage those commercial investments for our own applications, or how do we accelerate and encourage those investments here in the U.S. so that we can have the benefit of a wealth of commercial industry building, large unmanned platforms. So we're really looking for ways to be able to literally mine commercial industry and commercial investments. As far as the maritime domain itself goes, we're looking for ways to be able to better support cross-domain operations, and there's been a wealth of conversation yesterday and today about it, including with General Cartwright in the Enterprise Disruption panel about cross-domain operations. But what we really want is greater access for our systems, and there may be applications where pre-positioning or deploying a system initially in the undersea environment is a more effective way to service a target than flying something or floating something the entire way. So how do we pre-position in one domain to be able to support another domain? I think the maritime domain has always been one that's been good at cross-domain operations with Marine Corps applications and supporting ground troops over the last 20, 25 years. So what we're looking for is ways that we can deny the adversaries the benefit of these regions. How do we deny the benefit of the full ocean depths? Typically, our undersea operations occur really only in the first few hundred feet of the ocean depth, which is a mere fraction of what the ocean actually provides. So what we're interested in is how do we deny our adversaries the benefit of that full ocean depth, but also use that full ocean depth to conceal our own military objectives using the maritime domain. So the DARPA program managers have mentioned many times over the last couple of days that we all have a tremendous opportunity to come here to develop a vision and execute on that vision. So many of us come here with an idea, and we're given the tools, maybe a flashlight, to shine onto a dark spot of technology that maybe hasn't been developed yet. So what we're looking for is ways that you can help us shine light on these new ideas in support of disrupting the current maritime enterprise. So a few asks for you as the community for what we're particularly interested in, what I'm particularly interested in, is finding these new platforms and payloads that are good enough without quite being exquisite, and how do they fit into that big architecture. Second is finding interesting ways to be able to leverage commercial partnerships or technologies. I mentioned a few investment areas currently being made, but how do we exploit those for our applications? And then third is to find new ways to exploit the maritime domain, and to find new ways to exploit the seams that exist in the maritime domain, from the maritime to the air domain, or maritime to space, or maritime to the ground domain. And then finally, let's find ways to build capacity more quickly. Dr. Kennedy mentioned in his presentation this morning about the timeline to go from idea to commissioning for the Gerald IV, the new aircraft carrier. And while we recognize the incredible capability that platform offers, we also recognize that that's a timeline that we just can't live with anymore in the future. So how do we find ways to physically build platforms and deliver platforms to the fleet and get them in the time and place of their need far more quickly than we do now? In World War II, the average Liberty ship was built in 42 days. 42 days. How do we get back to that pace and that scale that we had in World War II? And with that, I thank you, and I will turn it over to Alexander Wallen.
Well, thank you. I'm Alexander Wallen. I'm a program manager in TTO. I came to TTO after a 22-year military career. And over that course of that career, I had an opportunity to work on some of those exquisite systems you heard about earlier today. In fact, as a young lieutenant, I got to work on something called the F-35. And then 18 years later, as a not-so-young officer, I worked on the F-35 prior to IOC. I actually worked on it 2 months prior to IOC. So in one sense, I got to see the entire span of the program over the course of my career, but that's something we're hoping not to repeat in the future. So I'll talk a little bit about that. I've had an opportunity to work with Andrew over the last year to search out novel concepts. And one of the things we're looking at is things that operate across both the air and maritime domain. And we're really looking at delivering effects traditionally associated with that carrier from non-carrier solutions. And we'll talk a little bit about some of the enabling programs, past, present, and future, that maybe feed into the vision that Andrew just laid out briefly well. So one of the past programs you heard about several times today already is the ACTIVE program. And Dr. Beutner mentioned it, and Andrew just mentioned it. For clarity, the entire program was named ACTIVE, but the actual vessel was named Sea Hunter. There's a great article in here about the ACTIVE program and the Sea Hunter vessel. I recommend reading it. And so Sea Hunter was designed as a medium-sized unmanned surface vessel testbed. And we transitioned it from DARPA, where we did the initial sea trials and the initial experimentation, to the Office of Naval Research in January of this year. And the ONR is continuing operations and sea trials with it. I think a good analogy to what we did with Sea Hunter can also be found in this document, and that's in the X-plane section, right? So there's a really good analogy between Sea Hunter and the AMBER program that DARPA did in the early 80s, which was really the first UAV. That UAV, nobody envisioned ever putting weapons on that system. Nobody ever envisioned things like Global Hawk and Dark Star and something that started like that turning into Reapers and caps of unmanned air vehicles. And I think that's really a good template for where we want to go, and Sea Hunter is really the first example of that. And what we're looking for here is, what's the next example? What's the next thing we build on to increase that capability? As I mentioned, ONR continuing to test Sea Hunter. They've actually ordered a second vessel. That'll increase the test efficiency, and also they're going to start looking at cooperative operations between multiple unmanned sea vessels. That's a really exciting area, I think, of future growth and something we want to explore. So I think Sea Hunter, a really good example of a past program, very near past, but a past program that feeds into this maritime domain disruption. A current program I currently have the opportunity to work is something called MADFires. So we realize on this panel that no matter how good of a solution we come up with, it takes a while to recapitalize an entire fleet, right? And I think General Cartwright mentioned the idea of resilience. You heard it again briefly here. I'd add onto that increased lethality. So if you can take that existing fleet and make it more lethal, more resilient, that can be as disruptive as well, because you're really disrupting what the enemy has spent time and money trying to do. So with that in mind, I think MADFires is a really good example of a program that does that. In the case of MADFires, it's a medium caliber projectile that's fired from existing naval guns, so we're using existing systems, but by applying new technology in innovative ways, we give it the precision and the range of a missile with the low-cost attributes you get from gun projectiles. So again, increased lethality, increased resilience at a low cost, and something that could be potentially disruptive to what the adversary is trying to do. So that's an example of a present system that we're operating in the maritime domain that I think feeds into the disruptive vision. The final example is a future program that feeds in that vision. And for that, as Andrew mentioned earlier, we're really looking for you, both academia, industry, DoD, what is that next program? What is that next breakthrough? We've got ideas on this side of the table, but I'm hoping after this forum, during this talk, afterwards, you guys come forward with your ideas of how we implement this vision. And that's really, I think, the true value of this forum, at least on this side of the table, is trying to get you folks in that part of the side of the table energized. And let's work on the next couple of steps, just like on that X-plane, to feed into this vision. So thank you, and Dr. Beutner.
Thanks, Andrew. So you heard about a number of ideas in the past hour: launch on demand, servicing satellites and maneuver in space, proliferated mesh networks in LEO. Thanks. Maritime operations on the seafloor, precision gun rounds. A few things that are disruptive in the possible future for warfare in all four domains, or the two that we're emphasizing now, space and maritime. With that, I'd like to go to some questions. We have a couple of questions at the top of the voting list here that are related. Let me just read them both, and then we'll take a few minutes and let each of the program managers respond. First, given that there are more ideas than funding, how do you select projects, particularly if you want them to be disruptive and maybe risky? And related to that, where do your ideas for programs come from? You, industry, labs? Who does your sanity checks for feasibility? Todd?
So I think the question talking about where do we get those ideas, I think they actually gave a lot of those already, is we get them from a variety of sources. Program managers come in with a vision. We like to talk about that vision, but a lot of that's seeing the art of the possible across industry, labs, academia, et cetera. One of the great things about DARPA is people are usually very interested and willing to share their research with us because we're very willing to fund interesting research ideas going forward. I think as for which things we choose, I think a lot of that has to do with impact. I think that the TTO's bar right now is really looking for things that are truly disruptive, not incremental changes, not an advance in a manufacturing technique or maybe one component, but we're really looking for something that can fundamentally change the way that we execute a military mission.
So I might just mention that there's a variety of different ways in which DARPA is able to fund technology development, and it doesn't always have to be at the scale of hundreds of millions of dollars for spacecraft development. It can be a much smaller scale. We have these things called seedlings, which operate at sort of the $1 million scale, which allow us to take an idea that could just simply be started as a quad chart and be funded and underway in very short order. We're also very active in the SBIR program, and we get a number of great ideas from small businesses, and we have the means to facilitate the development of those. So if you have a good idea, don't think that it needs to expand in scope to be very large very quickly. We can start small and work our way up, and we have a variety of different ways to facilitate those technology developments.
So I'd like to just add one thing to that. One of the definitions of a disruptive idea I found that I really like is if I need a new way of measuring goodness, right? And so I think, again, General Cartwright mentioned this, that prior to stealth, speed was the metric that we used. And then stealth came along and it became DB. And so the question is, whether it's space or maritime, if it's really disruptive, then I have to figure out a new way to measure goodness. And that's a good sort of a sanity check of if it's a really disruptive idea in my mind.
Let me jump in on the space. I mean, I'm specifically working on the Blackjack program, which is moving toward that proliferated low Earth orbit approach. And there isn't a DoD proliferated low Earth orbit satellite constellation in operation today. So in terms of what am I looking for technology, it's very specific. Well, not super specific, but somewhat so. 50-kilogram spacecraft payloads, maybe 100, 150 kilograms for some of those bigger, larger commoditized buses that can perform really good, high-utility military missions in that proliferated LEO environment are going to move forward with my office and what I'm going to be doing. So specifically, in terms of innovative, revolutionary capability, doing those type of ISR missions with just good enough, low cost, low weight, 50 kilogram being a low weight, payloads is what I'm kind of filtering through right now. And we have a BAA open, getting a lot of great responses. So I'm starting to see that door open. But that's the type of innovation specifically I'm going to be looking for the next few years. And then also just the question on industry versus labs, we see a lot from both, and really trying to gather the glimmerings from all the great commercial industrial space approaches that are out there right now is something I'm very actively searching to pull as many of those in for the benefit of the DoD that I can for the new proliferated LEO. Thank you.
I think opportunities like this to engage and just talk and chat are some of the best ways to get new ideas, or people that reach out to us and come in and brief us on some new technology, a new widget that, with a little bit of investment can mature the technology and can open up this new aperture for some greater change to the architecture. I also think that the ideas that come in that are the most helpful and useful are the ones that are kind of malleable. You might come in and say, I got this idea, but we might say, if you changed it a little bit here and squeezed it like this, and if you applied it to this, then this would really change how we do business. And so those are some of the more fun conversations that we get to have.
Okay. I think we've got time for just one more question. So again, for the whole panel, what future investments are you looking for and key technical challenges, or what are the key technical challenges that you see as being enabling for your future vision?
I'll jump in real quick. Back to the blackjack architecture. We're going to be building a lot of autonomy into these systems. We can't scale how we do exquisite satellite control. We can't scale other systems that are out there. We need to find a way to put a lot of autonomy to enable that low latency, that tactical timeline delivery of data, photon to the warfighter in seconds to minutes. To do that, we need a lot of autonomy software at multiple levels, at the payload level, at the satellite control level, at the constellation level. That's all new, and it's going to be an interesting way for us to push on DARPA here. What type of edge processor we're going to put on every blackjack node, high capability in terms of GPUs and FPGAs that can use future advanced software architectures, and then what can we do in the AI area to actually put on those hardware platforms to bring that level of autonomy that we want for the next generation of proliferated LEO.
So on the maritime domain, one of the things I think is key, especially when we talk near peer in the Pacific, is how do you get range, right? On small distributed platforms, and again, General Cartwright mentioned how do you get to the fight, or how do you get these things to the fight? If you want to be small, distributed, autonomous, you got to go a long way. It's a big ocean. There's a lot of area to cover. And typically the way we make things long range, whether on an airplane or a ship, is you make them bigger and you put more fuel in them. And so how do you break that range equation, I think, is one of the key technical challenges.
I will definitely footstop exactly what Xander said about the maritime domain. I think range and persistence is the big challenge. We like small systems because we think we can buy them somewhat cheaply, but can they actually get into theater, and can they actually stay there long enough to affect change? I think the other interesting thing with the maritime domain, and Dr. Kennedy mentioned it a little bit in his presentation this morning, is the idea of the transparency of the ocean. We do believe there is a future where the ocean will be somewhat transparent, so we're looking for ways to help accelerate that to our advantage in the near term, but also finding ways in this new architecture to mitigate that from a risk perspective from our side.
So I think that it's impossible. Every one of my colleagues so far has mentioned autonomy as a key technology, and when we think about what's going on in the on-orbit domain for servicing, for assembly, for manufacturing, and just this notion of a proliferation. Right now there's 400 birds in GEO, and you can kind of look at each one of those and they each have their own story, but the future that people like Rusty are trying to instantiate gives us thousands of these birds in LEO, MEO, a bunch of orbits. And we're not going to be able to have this situation where we have room full of operators for each one of these assets. And even when we're talking about doing a servicing operation, it can't be a room full of people and the robot arm moves 6 inches and you go, that worked. Let's wait tomorrow and we'll do the next one. It's going to have to be, today's job for one operator is to service one spacecraft. And we're far from that now. So imagining a future where we have the autonomy, we have the capability so that much, much fewer human minds are applied to operate these systems that have thousands and thousands of elements to them. I think that's a fantastic challenge that is going to take a variety of different communities to come together and make that possible.
I think with regards to space situational awareness, we're not yet there, but we're very close to being on the verge of a big data problem where we have so much information, a proliferation, coming back to the idea of transparency, so much data about all the spacecraft that are in orbit, coupled with a predicted explosion of, or I shouldn't say explosion, but expansion of the number of spacecraft that we're going to have. Keeping track of where all those things are, where they're going, advanced maneuvers, things that are coming in and out of the constellation, predictions of what's going to happen next. That's something that we're going to need a domain awareness of that we have in other domains, and we just aren't there yet for space. So I think being able to find a way to bring in that data and understand all that data is a problem that we still have not solved.
So with that, I just want to come back to something I said at the beginning. I hope that this is just the start of a conversation. There's lots of ways to engage with DARPA program managers, not just here at D60, although this is certainly your first opportunity, but also through our website. There's biographies and short summaries of areas of interest for all of our program managers up there and a means of contacting them through that. Our successes have always been built on the insights and the efforts of people like all of you. And so I value your insights and your engagement with us on how you think we can change the future of warfare and contribute to the defense of the country. Please take advantage of the time that you've got here to talk to all of us, but also follow up with us after D60 if you have some unique ideas. We announce our industry days through our website as well, and we have an office-wide BAA that allows you to send us ideas anytime. And one last thought, if there's an idea that you really are passionate about and that you want to pursue, and you can't get any of these program managers interested, Fred Kennedy and I routinely interview people for new program manager positions, and that's another way to make it happen. One of the things that keeps all these guys passionate is they all have a very short fuse. People come into DARPA for a very short period of time with an idea that they're passionate about and with their foot on the accelerator the whole way through. And our social calendar is made up mostly of farewell ceremonies for program managers on a monthly basis, which means we're also always hiring. And so if you have a unique insight and there's nobody that's really aligned with it right now, consider becoming the program manager and leading the country in that direction. And with that, I think we'll wrap up this session. Thanks to the panelists and thanks to all of you for coming.